This is a screencast for section 4.5, example 3. We're going to approximate binomial powers. Now, in example 1, you saw 1 plus x to the 1/2 power, or the square root of it. Now, what they're saying is that it's a binomial raised to a power. So if we use linearization, the process of making a tangent line to estimate the actual values of a curve, we will see that any binomial raised to a k power, 1 plus x to the k power, can be approximated by 1 plus k times x. And you're going to justify that in exercise 7 in your classwork. But from here on out, we can use this approximation straightforward, don't have to go through the whole process, and be able to quickly arrive at what will approximate the values of this using linearization. So for example, the cube root of 1 plus x, or 1 minus x, which is 1 minus x to the 1/3 power, by this then can be approximated by 1 plus 1/3, 1 minus 1/3 x. So 1 minus x over 3. 1 over 1 minus x, well, that's 1 minus x to the -1, so that can be approximated by 1 and then plus 1x, or just x. C, this would be, let's see, 1 plus 5x to the 4th, then raised to the 1/2 power. So I can take this u and substitute it in for x. The coefficient is k, so then it would be approximated by 1 plus 5/2 x to the 4th. Part D, this binomial is 1 minus x squared, and it's getting raised to the -1/2 power. This binomial is 1 minus x squared, and it's getting raised to the -1/2 power. So that can be approximated by 1 plus 1/2 x squared. So now if I wanted to know what the cube root of 1 minus 9 is, I mean, that's an easy one to do in my head, but I can also just plug in 9 to this approximation and get something approximate. It's a lot easier than taking a cube root in your head, multiplying or dividing by 3 and then taking 1 minus that. So much easier. The now try problem number 9 asks us to do something similar. We have a binomial raised to a k power that can be approximated by using the expression 1 plus k times x. So we're going to find the appropriate function to approximate values near x of these original functions. So let's see, 1 minus x to the 6th can be approximated by 1 minus 6x. Then, let's see, this would be, no, I need to rewrite this first. So this is 2 times 1 minus x to the -1st power. So I'm going to leave the coefficient 2 outside and use 1 now plus x to approximate the values of f of x equals 2 over 1 minus x, which could be 2 plus 2x, same thing. Let's see, this guy, 1 over square root of 1 plus x, so that's 1 plus x being raised to the -1/2 power. That can be approximated by 1 minus x over 2, or 1/2 x.